will make contribution is the 0.685, and it says there the row 2 will say does not make contributions. So the one who will not make contribution is the 0.315. So the total class in each column is 1. So it's the same with the Leslie matrix. No, it's not the same with the Leslie matrix. Do we have this one? That the sum of the numbers in the columns um, will not be greater than 1. It's only equal to 1 here. Okay, next. The next statement says 13% of the non-contributors will contribute next year. So the 13% will contribute. So our first statement there is making contributions, right? So 0.13 should be the first number in the second column. Now to get the percentage to those who will not contribute there, we have 1 minus 0.13, we have 0.87. So the 87% or 0.87 will not contribute next year. So as you can see, those in the top part will contribute, and then those here in the lower part or the second row will not contribute. Okay? And that's it. Now, oh, wait. The question says there the transition matrix. So you have to find that value, and that is here in letter C. Then as you can see, this value is the values here are equal with A and B, but they are not arranged properly. So C is the most appropriate value. Okay, next. Number 9. After 3 years, the number of members, which is rounded to the nearest integer, who make contribution is blank. So it will ask about the number of members who will make contribution. Okay, it's after 3 years. So as you can see, it is every after year here, correct? During any year. And then it says here will not contribute next year, will contribute next year. So this is after every year. So this is after 3 years. So what are you going to do? This is your P matrix, right? Or the transition matrix P. So you have to multiply that 3 times to your initial value. And our initial value is this, which contains this. Currently, there are 393 members who make contributions and 253 members who do not make contributions. So we have to multiply that with that numbers. So this is your X sub O, initial sector. Again, the top number will contribute, the lower part will not, right? So multiply that, the XO, multiply that P 3 times. So that's P cubed times X sub O. So you will get your X3. So first we get the X1. So compute for the 1 year. So P times X sub O. The result is this. Okay, that is your X sub 1 because you cannot multiply all the matrices here, or you can do like multiply the P class 3 times and then multiply it with the X sub O. It's okay. So here, by the way, it's better if you do it like this here at the side, because sometimes there are some follow-up questions. Yeah. If there is no follow-up questions class, you can do it like this. P, and then you multiply it 3 times the P, then multiply that with the X sub O with your initial. Your initial must be at the right side, okay, of the matrix. Okay, now we have this one. This is after 1 year. So after 2 years, compute year 2. We have X2 is equal to P, then multiply that with your X1. Okay, So your p, just copy your p, then multiply the x1, which is 302.10, and then 393.91. So I will not discuss to you, class, how to multiply matrix anymore, okay? You just do some practice on this one. And then this is your x1. Multiply that with p. The result is this. X at 251.65, 394.36. Now compute year 3. Plus, when you compute the year 3 class, the question is asking for, you go back, wait, okay. The question is asking class for the number of members who make contributions, right? So you are going to solve the upper number only. Oh, wait. So you will compute the upper number only there, the top number. So if you're done with the x2, you can stop solving class up to the top of your x3. Then you will ask like, can we just solve the top for x1, the top value, and then the top value for x2? No, class. You should get the lower value because you're going to multiply that with p again, and you need the lower value here in your x1, and you need also the lower value here, or the second row here, the number in the second row in your x2. Here in your x3, you don't need the second value anymore. So when you multiply the p there in the x2, so just multiply, when you do that, you multiply the row, right? The first row, multiply that with your x2 here, and that is your 223.62. And it says there we have to round it off to um, nearest integer. So it's here, 224 is the answer, and that is letter A. Next question. Find the stable distribution satisfying ax is equal to x. So this one class is finding the stable distribution, and it's not there in the slides. So it's better if you know how to do this. So we have a stable distribution is, you going to solve ax is equal to x, and you are going to solve for the x value there. Actually, that's the missing there. Stable distribution, just find the x. Okay, so ax is equal to x. So when you do this, you transfer x to the other side, so it becomes ax minus x is equal to 0, and your x is equivalent to ix. So that is why you can factor out the x there. So that's a minus I x is equal to 0. Now computing a minus I, um, you have this value. Your I is 1001, right? So the only numbers that you can minus with 1 is this numbers in the main diagonal. So minus that with 1. This is the result now. Now transform them into um, matrix. From matrix, you transform that into equations. And as you can see that when you multiply negative here in the first equation, they're just the same. So we need another equation class that contains x and y. Okay. So here we can solve the x here like this. Choose equation 2. You write it here. Or from the first one. Yeah, they're just the same because they're just the same, right? Um, Transfer the 0.13 y to the other side, it becomes positive 0.13 y. Now to solve the x here, you divide it by um, 3, 0.315 both sides, divide it there. So the 0.13 divided by 0.315 becomes 0.4127. Then there's a y there. So this is your x value, and we need another equation with x and y. So as you can see there, um, the total members class, the total number of members will remain constant. There are only 646 members because you have there 393 plus 253 is equal to 646. And that is just the initial number because they will change right every year. The number who will contribute is the same, is not the same with the number who will not contribute every year. So we can let that x plus y is equal to 646 because your x there is the number who will contribute and the y here is the number who will not contribute. Okay, so x plus y is also equal to 646. Now what to do? Substitute your x here now. So that is now 0.4127y plus y is equal to 646. Now your calculator can solve the y here, and your y value is um, approximately 457. Yeah, because there's a decimal here, they just round it off. Now what to do for your x? You approximate that also for 0.04127 times the y. Your y value is 457. So that is 189. And that's it. When you total these two numbers class, if you add them, the total is also 646. And that's it. We have there your x is 189 and your y is 457. And that is matches your d there. It's 189, 457 transpose. This number, right? If you write it as a transpose, it's like this in the column. And that's it. Next number, we have 11 and 12. Okay, for number 11, find all values of m such that E is a spanning set of R3. And we have an example for this one in our previous samples. Yeah, the previous one, the part one, you have something like this there. And what to do, we just pick the E1, E2, E3 there because E3 has a variable m, and we have to solve that m there. By the way, class, E will span of R3. Your m there has too many values. So there is only one value that will not make it a spanning set of R3. So we have to solve that. And it's here. Um, this is now your matrix. So what to do here? The first vector there, you write it in the first column. This is 7, -3, 1. Write that in the first column, E2 second column, and E3 in the third column. And you have this. Now solve the determinant. So I will not give much detail in solving determinants. You have lots of examples here already. And the last that we can solve is 40m minus 100. You equate that to 0 and then divide it by 40 both sides. Your m is 2.5. So that m value is the restriction. Your m should not be equal to that because it says here that if your m is 2.5, the determinant of m there becomes 0 because you equate this to 0, right? The 40m minus 100, you equate that to 0. It's here. 40m minus 100, it's equal to 0. So 40m minus 100 is your determinant of m. So if that is your m, the determinant becomes 0. Then E1, E2, E3 are linearly dependent. So it will not span your E, will not span R3 with that m because linearly dependent is not part of the definition of your spans. Your spans definition are the same with your linearly independent because as you can see there, they are the same. Their determinant of m must not be equal to 0. So for any other m, the determinant is not equal to 0, so it's linearly independent and your E will span R3. Again, we have this result, okay, in the slides. If the determinant is not 0, it's linearly independent and also E will span R3 there. So your M must not be equal to 2.5. And where is that in the choices? It's here, letter D. M is not equal to 2.5. Okay? So for all M, this is not true. And the others are not true also. So only that D is the answer. Oh my god, what is this? Wow, thank you, Lord, for the blessings. Okay, next. Questions 11 through 12. Yeah, that's it. That's your 11. And then for your 12, consider the following statements. Um, E is linearly dependent for all M. Letter B, E3 is linear combination of E1, E2, E4 for all M. Letter C, E spans a four-dimensional space. D, E4 is a linear combination of E1, E2, E3 for all M. And then E is a spanning set of R3 and E5 is a vector in R3. Then we have E1, E2, E3, E4 to E5 is also a spanning set of R3. So find all correct statements from the above. So I'll give you some explanations here in individual letters. So understand E. Your E there has four vectors in R3. So four vectors in R3. So any set of four vectors class in R3 is automatically linearly dependent. Please take note on this. Why any four vectors? Because as you can see, only three vectors in R3 form a basis, right? And bases are linearly independent. So if you will add another vector class, it will not be linearly independent anymore. Okay? Adding one vector there will make it linearly dependent. Okay? So letter A, E is linearly dependent for all M, and that is correct because again, your E there has four vectors. It's automatically linearly dependent. Next, letter B. Um, E3 is a linear combination of E1, E2, E4. So we have here some reasoning. So as you can see, class, in your E3, you have a restriction there that M is not equal to 2.5, right? In your E3. So that is why it says here linear combination of the three for all M. He says for all M, but no. There's an M here which is not equal to 2.5. That will make this a false statement. So B is not correct for all M. Now letter C. E spans a four-dimensional space. Impossible, class, because R3 is only three-dimensional. So maximum span is three-dimensional. C is incorrect. Letter D. E4 is a linear combination of E1, E2, E3 for all M. So this one is always true because the set E there has four vectors in R3. It will always be linearly dependent. And if it's linearly dependent, class, it is a linear combination. D is correct. Next, E. E is a spanning set of R3. And E5 is a vector in R3. If you will add another vector dash class, it's also a spanning set of R3. And you will say, this is true. If E spans R3 already, adding any vector e5 in R3 doesn't reduce the span. So it remains R3. So E is correct. So we have three letters that are correct: A, D, and E. So that's letter B. You pick letter B there: A, D, E. Next, you have there. Okay, this one also class null space. I guess this is not there also in the slides. So this question, and as you can see, class null space. Mm, this one is a basis of a null space of A. So determine I and J. So by the way, class, a null space is from the word null itself, null space. The elements there are equivalent to the zero matrix. So if you multiply A by any vector here in your basis, the result is always a zero matrix. Okay, so we have this. We determine I and J. Then, as I told you, A multiplying with any vector is equal to zero matrix. So that's A here times E2 also is equal to zero. So first we have A times E1, A times E1 here. Multiplying that value, we have this 5i plus 2, and then 10i plus 4 is equal to 0. So I just equate the top part class 5i plus 2 is equal to 0. Then your I there, if you solve it, transfer 2 to the other side is negative 2, divide 5 both sides. So the I there is negative 0.4. Then as you can see, they have the same value here in the lower part. Why? Because the lower part plus the lower row is just multiple of 2 here, right? The first row, multiply that with 2, the result is the second row. So if you solve the I value here, 10i plus 4 is equal to 0. The same I that you can solve, I is also negative 0.4. Now A times E2, so this one multiplying with this, the result is this one, 5j plus 4 and 10j plus 8. So equate that to 0, so I only get the top part. 5j plus 4 is equal to 0. Transfer the 4 there, becomes negative 4. So 5j equals negative 4. Divide 5 both sides. Your j is negative 0.8. So that matches your letter D there. Okay. Then you will solve also the j here in the lower part, the same number that you can solve, negative 0.8. So we only pick letter D there in the choices. It's here. So please do not be confused because as you can see, B has almost the same numbers, but they are interchange. I here is 0.8 and then J is negative 0.4. So D is the only answer. By the way, class, this questions from 13 through 16. If you will get a wrong answer here in 13, you will get wrong answers also for 14, 15, and 16 because they will use the I and J there also. So class, be careful sometimes in the test that you have to make the first question there should be, you should have a correct answer. Okay, please, you have to double check the first question. If you see something like this, questions 13 through 16, just an example. So the question 13 there, you should do your best there because sometimes you use that in answering the next questions. And that's it. And which is true to this example. We will use that I and J value to answer 14, 15, and 16. So it's here now. Again, null space of A is the same with this, null of A. Find M such that the vector X, which is equal to M minus 1, 1 transpose, is will belong to your null A. So we find the M there. So what to do? It should be X plus, should be X is equal to alpha E1 plus beta E2. So what are we going to do now is to solve the M. Okay, so first, M plus the first component. You can use any variable here that you want. This is alpha and beta, so maybe you can use A or B or lambda 1, lambda 2. It's up to you, class. So this one, x is equal to this, and then alpha times E1. This is your E1, I10, and then your E2 is J01, right? It's there in the given. So combine all the first components. So M is equal to alpha I, then plus beta J here. That's the first component. Second component, negative 1 is equal to alpha, because alpha times 1 is alpha. And oh, the zero here in the second component, so there is no beta. Now next, third component, we have 1. Oh, your alpha here is 0. Then beta times 1, so it's beta. And this is very easy. Your alpha is negative 1 now, and your beta is 1 already. And again, your I is negative 0.4, and your J is negative 0.8. You can substitute it now in the first equation, the values of your I, J, alpha, and beta. You have there, your alpha is negative 1, your I is negative 0.4, your beta is 1, and then your j is negative 0.8. And solving that, the answer is negative 0.4, and that is letter B there in the choices. So here, class, in answer number 14, they use again the value of their I and j. So number 13 answer is very important. Next, number 15. Question. Oh, find the coordinate vector of x. And you know this already because we discussed the coordinate vector of x. The coordinate vector of x with respect to the basis e, we have there x e, right? You write x there inside the bracket and then e in the lower part. So how to do that? Your x is here already in 14. So you have to use that x. Mm. And that's it actually, class. You use that x and then equal to an alpha times e1 and then beta times e2. And actually, you are just going to solve the alpha and beta there. And we solved it already. So your xe is equal to this, negative 1, 1 transpose. And that is letter B there. So for number 15, we use the previous answers from 14, right? Previous solutions there from 14. So again, class, questions here are very related with the previous questions. If you have a mistake in the previous question, then you have probably a mistake also in the next question. Next, number 16 here. We let F be another basis of null A, and then change the basis matrix from E to F. So we have here P is equal to this one, 1, 1, 1, 2. And U is a vector in the null space A, where UF is 3, 2. Find the vector U. So we are going to find the vector U. And we have this formula. Your P is there, and then your UF is this one. Now, your UE is equal to the P inverse of your UF, because this is the second vector, right? The second base, UF, second basis. So actually, the first base, it should be P times UE is equal to UF. Transferring P to the other side, that's why we have a P inverse here. Now, this is your P. Get the P inverse, you have this. So I will not, the question here, or the solution here, class, didn't give you the solving how to get the P inverse, because that's basic for the matrices. So you have to get the P inverse by yourself. How to do that again? That is 1 1 1 2 here, right? So you will add like in identity here at the side. So you had 1 0 0 1, and then you make the numbers here the same with the identity. So you have to transfer this one, make this 0, the one here in the lower, the two here make it 1, and then the upper here make it 0. Then the other side of the numbers here, the four numbers there, becomes your entries in your P inverse, and this is it. Now P inverse times UF, because your UF is given 3 2, it's there. When you multiply that, it's 4 1. So your 4 1 is your UE. And the question there is asking for the unit vector U, no, the vector U, right? So we have there U is equal to, we need this UE. You have to multiply this with the E vector. So 4 times E1, and then plus -1 times E2. And that's it. Your E1 is this, and then your E2 is this with I and J there. In combining the first component, we have this. Second component is 4. The third component is -1. And you have there again an I and a J there. So you substitute the I and the J values that we solved. It's -0 0.8. So -0 0.8 for -1. That is now your U. And where is that? It's here, letter D. And that's it. That's the end of the part two. And we will now have our part three. By the way, class, again, the slides are there already in your LMS. Please see it. If they are not there, please tell me, inform me. Okay, and that's it. So I will now close this, and it's time now for your break time. 10-minute break, and then see you after 10 minutes. Okay? Hello, class. Can you hear me? Hello. Yes. By the way, maybe you can hear some noise. Oh, it stopped. Uh, there is someone who's using something for, and it's not noisy anymore. But maybe you can hear them later. Okay, let's continue. So we are now in the part three. By the way, did you find it there already in the LMS? Someone said it's not there for TTO1 because you have there two LMS. I uploaded it. Yeah, did you hear that? Oh my God, it's very noisy here. By the way, did you find it there already in the LMS? Is it a yes or a no? Hello. Did you see it there? No, no one is responding. Hello. It's our linear algebra MT1007 Nguyen Tien Dung TTHK243 TTO1. You're TTO1 class, right? Did you see it there? Hello. I wait. Yes, yes, I can find it. Thank you. So it's there already. So we will continue now. Okay, share screen. Did I share it already? So it's here. And where is it? Oh, hello, where's the slide? Okay, it's here. Part 3. Yeah, we have this one. And part 3 class, this is the latest exam that they had. It's from March 2025. Class, I reviewed you a lot of exams, previous exams. So I am expecting a lot from you, from your scores there. Okay, you do your best. Okay, so we have here an A, be a square matrix of size n, and I is the identity matrix of the same size. So choose the correct statement. Plus, if your A is equal to A squared, what is the next statement? Is it the rank A is equal to n, letter A? C, A is not invertible. D, determinant of A is 0, or determinant of A is 1. And then E, there A is equal to A squared, then A is 0 or A is I. So which is the correct one? The answer is letter D there. The determinant is 0 or 1. So we have here some reasons why A, C, and E are wrong. So we have this A squared is equal to A is called projection or idempotent matrix. By the way, this topic is what is located at the last part of our um, lesson. It's not there in the discussion yet, but these eigenvalues will be discussed in the finals. So I just introduce it. We use this one to show this part here. So the eigenvalues of A must satisfy lambda squared is equal to lambda. So your lambda is 0 or lambda is equal to 1 if you solve the lambda here. Correct? It's 0 or 1 because you make it lambda squared, transfer the lambda there, minus lambda is equal to 0. Then factor out lambda. So lambda times lambda minus 1 is equal to 0. So when you solve the lambda there, lambda is 0 or lambda is equal to 1. Now, the determinant of A is the product of the eigenvalues. Again, the determinant of A is the product of eigenvalues. So it is either 0 if any lambda is 0, or it is 1 if all the lambda is equal to 1. So when you multiply the product of eigenvalues here, that will be the determinant of the A. So 0 times 1, it's 0. And then if all of them are 1, it's 1. So determinant of A is 0 or 1. The answer is D, which is correct. Now, letter A. Rank is not necessarily n. It's their class. Um, because it says that if A is equal to A squared, then the rank of A is n. Okay, you can find an A there as an example. For example, your A there is zero matrix. When you square it, it's zero. And the rank of A there is not n anymore. Correct? And that's it. No? So that is false. Also, if your A there is the identity matrix, because when you square it, it's also an identity matrix, right? Okay. So, the rank of the identity matrix. Ah, yeah. Sorry, we cannot use that because the rank of the identity matrix is n. So when you square that, the rank of A is n. So that's an example that will show this statement as true. By the way, you will tell me like the E here. You will say, oh, E is correct if A is equal to A squared, A is equal to 0 or A is equal to I. Because when you square the 0, it's the 0 matrix. And when you square the identity, it's also the identity, right? But class, the if part there is the first to um, to satisfy. So if this statement is reverse, if we say that if A is 0 or A is equal to I, comma, then A is equal to A squared. And that statement is true. Okay? So if you reverse the E here, class, that if A is 0 or A is equal to I, comma, then A is equal to A squared. That is the statement which is true. Because when you square a 0 matrix, it's still equal to 0 matrix. And then when you square the I there, it's still the identity I. So that's it. Your E here is false because that's you have to satisfy first A is equal to A squared. And that A there, it's not only the 0 matrix or not only the I matrix, the identity matrix, that when you square the A, it's equal to A squared. But if you reverse that statement, A equals 0 or A equals I, then A is equal to A squared. That's true. Okay? That's it. So only D is the correct answer there. Next. Okay, wait. There's another explanation for the C part. Not necessarily true. A equals I is idempotent and invertible. So C there is not necessarily true. It says there A is equal to A squared, then A is not invertible. But you can make the A there is as equal to your I, right? Because when you square the identity, it's the same. And I class is has an inverse. It's invertible. Next, false general. By the way, what is the inverse of the identity matrix? Okay, can I ask you that question? What is the inverse of the identity matrix? Can someone answer it in the chat box? Please go there now. What is the inverse of the identity matrix? What's the answer? Hello. No one is answering. Do it fast, please. What's the identity of the identity matrix? No, no. What's the inverse? Inverse of the identity matrix. Please answer it. Hello. Any identity matrix I am referring. So what's the answer, class? What is the inverse of the identity matrix? If you cannot answer it, then we will not proceed. I will not discuss the next question. No one can answer. I only need one answer. Now you search it in the internet. It's not fair. You answer it now. What's the inverse of the identity? Correct. Still I. Because when you have identity matrix, you pair it with identity matrix here at the other side, right? And you will make the that matrix there be identity already. So the other side there is the inverse of itself. It's still identity. That's how to get the inverse, right? You forgot it. You should answer it directly like you know that's it's inverse. Yeah, but the slides didn't tell you, right? That's the inverse of the identity is itself. Next, E. False in general. Projections other than 0 and I exist. So it says there that there exists another A's class that when you square it, they are equal. It's not only the A is equal to 0 and A is equal to I. And I told you that already, right? There are some other matrices that when you square it, it's the same with itself. Now we have number two. Let A, B, and C be equal to that. Find a matrix X that satisfies the matrix equation XB plus 2X A transpose is equal to C. So this one class, even if I will not discuss this, you should get that. You just multiplication and addition and then transferring it to the other side. It's for the inverse. Okay, so we have this. This is your A, this is your B, this is your C. Now, the equation is this. You can factor out x outside. So x times b plus 2at equals c. Now, when you transfer this b here plus 2at to the other side, it should be, since it's in the right side of x, you have to multiply the inverse in the right side of your c. Can you hear that noise? Oh my god, they are repairing something. So A here and then A transpose, just change the row here is negative 3, 4, write it in the column, first column, and then the 5, negative 1, write it in the second column. That is your AT. Now it says there multiply that with 2, so 2AT is this, multiply all the numbers there by 2. You have that result, then add it with B. Your B is there, 1, negative 10, 8, 9. So add them, the answer is negative 5, 18, negative 2, 7. And this is now your B minus plus 2AT is equal to 1344. This is your C. Now you had to get the inverse of this, and I will not get that for you. So you have to solve the inverse of that, multiply it here in the 1434, and you will get this value 15, 29, negative 38, negative 74. And that is in letter A here. Letter A is the answer. Okay, next. Questions 3 through 4. So let x be this one, and a is equal to 2x cubed. Find the determinant of a. Hmm. So to find the determinant of a class, you have to find the determinant of the x first. And the determinant of the x here is 1 if you solve this determinant of x. So we have here 2x. Now, class, look at what is your matrix x there. Your matrix x is 1, 2, 3, 4, 5, 6. This is 6 by 6 matrix. So you have to raise the 2 there to the power of 6. Okay, so it's here. Um, determinant is for 6 by 6 matrix, determinant of 2x cubed. This is now your A, right? So it's equal to 2 to the 6, then determinant of x cubed. So 2 to the 6 is 64. Determinant of x, you cube it. And determinant of x there, class, is just 1. So cube that. It's 1 cube, it's 1 always. So 1 times 64, your determinant of A is 64. So letter A is the answer, 64. Next, the other choices are too far from 64. 2 and the negative 2. My God. Okay, next. Oh, applying the following row operations in a given B matrix. So class, you have to apply it on the B. We obtain the matrix A. So it means that the matrix A is equal to the matrix B. Then you apply the changes here in your matrix B. Okay? So changing the rows, it means multiplication of 1, negative 1. I write it there already it's there in the slides, class, of the determinants, and also it's there in what did I do? The previous example, we have this one already, but it's different way. But the changing the signs, it's there. So you have your determinant of A is equal to this one, determinant of B times the changes that we will apply. So first, when you change the rows, interchange the rows, will change the sign. That is why I multiply that with negative 1. Next, R2 map to 3R2. So you multiply 3 here. You have to multiply 3 also in the determinant. Here you multiply R3 here with 1 half. So multiply this also with 1 half. Again, class, the minus and the plus will not change the determinant. Here, R4 only. So you only multiply it with 1. So no change in the determinant here in the fourth change. Okay, so you only have negative 1 times 3 times 1 half. It's negative 3 over 2 determinant of B. So this, your determinant of A is given 64 already. This is your answer from question number 3. So if you have a wrong answer there in question number 3, you will get a wrong answer here also. So you have there 64. Transfer the negative 3 over 2 to the other side. It becomes negative there 2/3. So we have here negative 64 times 2 over 3. The answer is negative 128 over 3, or approximately equal to negative 42,667. And that is found here in letter D. Next, number 5. If this is your A, find f of x is this, find f of a. Oh, we have an example of this already. So we have there a squared because it's 3a squared plus 5a minus 5i. So we solve a squared first. 954,036. So substitute it here, multiply it with 3. This is the result, 27, 162, 108, 0. Now multiply 5, your A entries there, so it becomes 15, 0, 30, 30, and then negative 5. Your negative 5 there, class, you have to multiply that with the identity, which is 1001. So it becomes negative 500, negative 5. Now add the first numbers here. 27, 15, negative 20, negative 5, it's 37. 162, 30 plus 0, 192. 0 plus 0 plus 0, it's 0 here. Then 108 plus 30 plus negative 5, the answer is 133, and you can find it in letter D here. Letter D. Correct? That's it. Next. Oh, Leslie Matrix. Um, we have this Leslie Matrix class, and this is a different one. The previous one class is the top there are the BIs, right? The birth rate B1, B2, B3, and then P1, P2. So what if class there's a P3 probability that the third class will survive? You have to change the number here, the last zero here. You change this for your the third, the percentage of the um what they call the survival rate of the third class is located here. The last zero. It's the last column. It's located at A33 entry. Okay? So we have here problem 0 to 20 years old, 20 to 40, and then greater than 40 years old classes. So after 20 years, so it's every after 20 years class, okay? About 74% elements in the first class, 55% elements in the second class, and then 29% elements in the third class survive. So as you can see here, the survival rate percentage, we have 74, 55, and 29%. So 74% must be here, the second row, first column. 55% should be here, um, third row, second column. And the 29% must be here in your A33. And it will satisfy letter E. You see it here in the letter E. Only E got that. The rest are wrong. Okay. Next, we will check if the top numbers are correct. And it's here, the birth rate. Look at the birth rate. First class. Birth rate of the first age class is 1.2, which is correct here, 1.2. Second class is 1.3. It's here. It's 1.3. And the third class is 1.5. So 1.5. So letter E is the only correct answer. And that's it. It's there. And this is the arrangement class. P1, P2, P3 must be here. Okay? So this is new to you because there in our slides, the P must be in this diagonal. Since there is additional percentage of survival for the third, it should be here. Okay? Because you will not you are not allowed to add another row because it will make a 4 by 3 matrix. It's not a square matrix anymore. Leslie matrix are square matrices. Okay, so please wait a little. Okay, so class, this example is new to you because of this one. And now that's the number 6. Next, number 7. After 60 years. Now, class, the problem, it's always after 20 years. So we are going to multiply our matrix A there to this x sub o three times because this is 20 years. So multiply the a there in your x sub o, that's only 20 years. Multiply it again, the a here in your x sub o, it's for the 40 years. And then when you multiply it again, it's now for the 60 years. So we multiply it there three times. So this is your x sub o. So that's it. First, multiply that with a x sub o. This is your first year. First 20 years. This is after 20 years because it's here. Each time step is equal to 20 years. So 60 years is three steps. So we have to find x3. And the question there says, find the number of elements in the first class. So class, no need for you to solve the second number there in your x3. So first you have this, multiply it here in your a, and you, yeah, 600, 200, 300. That's your initial, multiply it here. The answer is this. Okay, next. Ah, what's the next slide? X2 and X3 are here. By the way, class, solving your X3, you have to multiply this x2 in the first row there in your A, okay? And you will get the first component already, 4934. By the way, no need for you to complete the x3 matrix. No need for you to compute the 1916 and the 669. And that's it. And that's the shortcut for answering this question. The answer is 4934, which is letter E here in the choices for number 7. Next, number 8. By the way, this system is the same with our previous question there, and it's asking only for the current I1. It's number 6 of the part 1 class, and I revised it there already. That's how to get it correctly. Okay? So, first is, but this question now is asking for all the currents. That question there in the number 6 from your part 1, it's only asking for the current I1 there because it says that what is the current that will go through R1. But now you're going to find now I1, I2, and I3. Which of this is the best choice? Okay, so we interpret this circuit first. So if you have this circuit here, the left loop, if you go here with R1, the current will flow R2, and it will also flow here in your R3. So that is why I1 is equal to I2 plus I3. It's here, I1 is equal to I2 plus I3. Next, left loop. 10 is the voltage. So when you go here, you went through R1 and R2. So your R1 is 4, your R2 is 1. So that's it. Your 10 volts is equal to R1I1 plus R2I2. Go back here. Here. Um, Second loop. You go here. So 10 volts is equal to, when you go here in R3, it's normal current flow because in your A there you say that this will flow here. Correct? So R3 times I3. Now class, when you go here, your R2 goes in a different direction now. Okay? So that is why your R2, your I2 here, the current, you change the current here to a negative. And 10 plus R3 I3, you can use the minus here, R2 I2. Okay? You can change this plus here to minus. And then your I2 is fixed. Your I2 is always, when you transfer the I3 there, it's I1 minus I3. Okay? Your I2 is I1 minus I3. Now, if both of them has I2, what to do? You solve the I2 here in your first equation because you're going to substitute it here in your equation 1, equation 3 and 2, because when you substitute there the I3 and I1, all the currents here are all I1 and I3, and your calculator can solve that. Then after that, solving the I1 and I3, you substitute it there in your equation 1 so that you can solve I2. Okay? Now, class, look at what happened here. Why I use plus there? Because I will interchange the current I2. As you can see here, the I2 is equal to I1 minus I3, right? And look at here in the right loop, I make it I3 minus I1. I change the I2 here to I3 minus I1 because this is the negative version of the current I2. You just change it. Interchange the I3 and I1 in the minus. This is minus, right? Your I2 is equal to I1 minus I3. And here I change it. So this is not the negative version of your I2. When you multiply negative there in your I2 class, it becomes I3 minus I1. Okay? That is why if you change this here to minus, if this one is now minus here, the plus here in the third equation, if this is minus plus, your I2, do not change it. It's always I1 minus I3. And that's the same with this. If you have a minus here outside, and then this is I1 minus I3. Okay? They're just the same. Now solving here the top part, you have there an I1 and I3, and here an I1 and I3 also in the equation too. And your calculators can do that. You can replace I1 there by X because there is no I1 there in your calculator, and then your I3 you can make it a variable Y there. And your calculators can solve I1 and I3 directly. So I1 is this one, 2.8571, and I3 is equal to 4.2857. Now for your I2, again, you go back here. This is I1 minus I3, right? So that's it. You have your I1 and I3 already. You minus it, it's negative 1.4286. So class, the current class is always positive. When it is negative, it just says that the direction is changing. You have to change its direction. Okay? That's only for the direction of the current. So the answer that satisfies the three numbers there is letter D. Okay? It's letter D. Maybe you will say like, oh, the I there is negative. Mm, I told you already. It's always positive. The current is always positive. But if it's negative there, it means that the direction that we choose is wrong. It should go to the other direction. Okay? And that's it. And you will say like, um, if this is positive, this is I1 minus I3. What's the direction of this? The direction of that class is here. Your R1 will go here, and then your I2, your R2, the current R2, you go here, right? In this part. Mm. So that is wrong. Your current must go there to the other side. Your R2 must go there. So in the A here, I1 will go here, and the current in the I2 in the R2 will go here also. Will get inside the A, and the output of the current will be here. Flow in. There flow in here in A and flow out here. Okay, that's it. Next, number 9 and 10. Oh my God, we only have 8 minutes. Uh, Find M such that the system has non-trivial solutions. Can I do it fast? Okay. Um, Solve the determinant of that system. Mm, just get the numbers there. Okay, and that's the numbers here. Now get the determinant. It's equal to m, the m, make it 0. You equate the determinant to 0, and your m there is negative 5.333, and that is letter D. Okay? You will say like the m there has a non-trivial solution. Okay? Next. Oh, number 10. Number 10, with m found in the previous question, so class, you have to get the right m value there. Find the general solution of the system. Okay, general solution of the system, class, is the value of your x there, the y, and the z. And it says they're non-trivial solution, right? Okay, your m that we are going to use here is the negative 16 over 3. We will not use the negative 5.3333 because this is just approximation. And the decimal there will continue, right? So we have to use this fraction so that it is more accurate. So here is negative 16 over 3, and you use the m there now. And it says there, because determinant of because the determinant here is 0, there is one free variable. So, and it's also rank 2. The rank is also 2. So we have one free variable, and we choose here the z part. So z is equal to alpha. If your z class is alpha, first we use equation. We only use class 2 equations for here. Do not use all the three. So but since this is rank 2 class, so your matrix, your row 3 here will all be zeros if you will do, will you convert this into reduced row echelon form. So we only need row 2 and row 1. So z here is alpha. You substitute in the z because this is a free variable. Substitute it there in your second equation, which is there 1, 1, 2. So we have here. Now, equation 1 also, you replace the z there by alpha, so negative 2x plus 4y plus z is equal to 0. So z now is alpha. Now, here in your equation 2, you solve here the x, which is equal to negative y minus 2 alpha. You substitute that the x here so that we only have y and alpha here. Now solve the y. We have y is equal to negative 5 over 6 alpha. Now substitute this y here in your x, which is this one. So we have negative of the negative 5 over 6 alpha minus 2 alpha. It's negative 7 over 6 alpha. So this is now your first term. We just factor out alpha here outside. Now we multiply that with negative 6 so that it's an integer. So negative 6 multiplied this with negative 6. This is 7. Here we have 5, and then 8, and then the 1 becomes negative 6. And you can find it here. Letter, where's 7, 5, negative 6? It's here. Letter B. My God, too fast. Letter B. Here. 7, 5, negative 6. And the other choices are different from them. Okay? So it's not the same with the 7, 5, negative 6. Next, we have here number 11 through 12. You have the E1, E2, E3, be the vector set, and find all the values of M such that the V is not linear combination of E. Okay, so we have this three vectors. You arrange them in columns, and then your V1 to M, and it says there is not a linear combination. So your M is not a linear combination. So we have this. We solve the following. We make here 0. The number here is 0, 0. Then this is 1, 0. This is 0 also. So we have now 1, 0, 0, 1, 0, 1, 0. And this is your M here, the last number. So the M there must be this one, the M minus 1 third plus 7 over 3 times negative 13 over 29. This must be 0. So if that is 0, we can solve it. M is equal to 40 over 29, and it is approximately 1.3793. This one class, if your M is a linear combination. Now, says there that the V must not be a linear combination, so it should not be equal to this value. M must not be equal to 1.33793. Where is that? Letter D. It's here in letter D. It's not equal to 1.3793. Okay, next. So we have lots of values of M there that it is linearly a linear combination. Next, we have here number 12, following statements, and then you're going to find which is true or not. So only A, B, E, and F are true. So you pick letter A there. A, B, E, F. And we have some reasons there why D and C are false. Okay. 13. Find all values of M such that E is a basis of R3. So we only have 13 to 16 class questions. Okay, can we continue this one? Um, but if you have another class, you can go there. Okay. So here we solve the determinant and it should not be equal to 0. So your M is not equal to 17407. And that is here, letter A. Next, given E is also a basis of R3, the transition matrix, we have this P here, and then let U be the vector such that UF is this, find UE. So the UE class is this XYZ here. You multiply that with PF to E, and you have there UF. This is the given UF. Now you solve the X, Y, and Z there, then the answer is this. Your X is -7, your Y is 3, your Z is 14. That is your UE. Okay, so to solve this, you can make it like an augmented matrix. Then you make the numbers here be the identity numbers like 100, 010, then 001. So the other number there at the side will form this numbers -7, 3, and 14 there. Okay, next number 15. Find the vector u. So if you're going to find the vector u class, you have to use there the UE that you get because you multiply that with the E1, E3, and E1, E2, E3. That's it. Multiplying that with that numbers and then get the first components. It's equal to 2. The second components, you add it 77. Then the third component, you add it's -13 plus 14M. And that is equivalent to D here. So D is the answer for 15. And last number we have 16. Find all the real values of M such that E is a basis of R3 and U belongs to G. G is this, where U is given in the above question. So you have there U. So class the U answer in the number 15 is in the 15 is very useful. Okay. So you have this 277 -13 plus 14M is equal to alpha times your 2 minus 4 plus 1 plus you multiply this with beta, beta 2, 2, 1. So we use the vectors here in your G1, G2 belongs to G. Your U belongs to G. So class, there is a mistake here. This is not equal to M. This should be G here. This should be the vector set G. Okay. Ah, sorry. It's the G is here already. G is a linear span of the vector set M. So that should be M there. And that's it. It's not a mistake. Okay. Now we have their alpha, beta. Compute the first component. So 2 alpha plus 2 beta is equal to 2. So when you divide it by 2, your alpha plus beta is equal to 1. Now, second component, we have here 4, negative 4 alpha plus 2 beta is equal to 77. Correct? Now, what to do? We combine it. Your beta there is, since your alpha plus beta is equal to 1, beta is equal to 1 minus a. So substitute it here in your beta, and you can solve an alpha, which is 12.5. Now substitute your alpha here. So your beta, you can solve it. Your beta now is 13.5. And then what to do? You check the third component. Yeah, for the third component class, you have there negative 13 plus 4m. Your alpha is 1, alpha times 1, and then plus beta times 1. So your 13, negative 13 plus 14m is equal to alpha plus beta. Okay. And which is actually equal to 1, right? And then negative 13 plus 14m is equal to 1. Transfer 13 there to the other side, it becomes plus 13. So your m there is equal to 1. And that's it, because the question says find all the real values of m such that e is a basis of R3, and you have there m is equal to 1. And that's letter E. And that's the end of our review. By the way, good luck class with your midterm tests. Okay? Goodbye everyone. Thank you for joining our class today. Goodbye. Are the questions in the exam similar to what we have reviewed? Um, by the way, class, as I have told you, I didn't see the test, and then they just said that I have to review previous exams because the exam questions are related to it. They just said related, okay? It doesn't mean that it's similar. Okay, so you have to analyze also all the questions there, what they are asking, and that's it. Goodbye, everyone, and study hard. Okay, do your best. Bye. So I reviewed you a lot of questions for you to see a lot of examples how to solve those problems. So it's up to you now to take the test, and I hope you are ready. Okay, bye. Thank you for joining again.